So I'm going to go ahead and do my best here to give you a crash course in the unit circle, just to try to get a little bit better understanding of the process, of the numbers, of the patterns, in a way that can help you do your trigonometry and your graphing and all the things we're going to be doing with Unit 6 and 7 faster. The biggest thing here is the unit circle is a pattern. It comes from a circle centered at the origin. So here's the origin, with a radius of 1 everywhere. Okay? The length's 1 there. Obviously, I know down there it's negative. We have -1 this direction, all that stuff. Okay, so the first part, so let's just talk about the basics. So I just said the radius is 1. So if the radius is 1, the unit circle's measurement starts from the far right corner here, or right side, you could say, and it's at the value of 1, 0 for the coordinate. Okay? And so the coordinate here, when we go to the top, is 0, 1. We go over here to the left, it's -1, 0. And we go to the bottom, it's going to be 0, -1. Okay, so those are our coordinates that in terms of like key locations, in terms of the endpoints of our unit circle. And then the unit circle, I'll go ahead and just go over the degree cuts, and I'll talk about the relation to radians as well. But we know that a circle does, everybody should know, that circles are 0 to 360, so I think the degrees are the easiest for people to understand. So 0 to 360 is our form for the degree measure. Okay, and so then we know, like, think about it, like this right here, that's a 90-degree cut. So this is 90 at the top. And there's another 90-degree cut. This is 180. We also know half a circle is 180. Okay, and then down here, this one's 270. I should have left a little bit more room here, but 270 down here. Okay, so those are your main locations. Now, the unit circle is broken up, which I'm going to talk about on the next slide, into special triangles. Special triangles build the unit circle, and they are triangles that are 45, 45, 30, 60, 60, 30 triangles. Okay, we're going to talk about those in a second. But the point is that they have those specific cuts. So they have a 30-degree cut, 45-degree cut, 60-degree cut, all the way around. But then it just changes because now I'm adding 30 to 90, so 120, 135, excuse my human error here, 150. Then 180, the next one, 30 is 210. Okay, and then we have 225. Then we have 240, 270. Then 30 from 270, we're at 300, 315, and then 330. So those, whoops, extra 3 there. We have all the values of the degree measure for the unit circle on here now. That's all the cuts. Okay. Now radians is where it gets a little bit confusing for people. I'm going to try to slide these in the best I can. I might use a different color here. It might help. So let's go ahead and just go with blue for radians here. So radians is more of an arc length measurement. So rather than the degree angle, it's the length in terms of around the circle. Now since the circle is a radius of 1, we know the circumference. The circumference is 2 pi. Why? Because the circumference of the circle is 2 pi r. So if it's 2 pi r, it's 2 pi times 1. And so radians cuts that measure in terms of arc lengths around the circle. So we have this case, instead of going 0 to 360, we're going 0 to 2 pi. And so you have to kind of change your way of thinking. I mean, in an ideal world, wish it was 0 to 1, but it's 0 to 2. So all the way around is a 2. So then if all the way around is a 2, let's just stay simple. What's halfway around? Well, if from 0 all the way around is 2 pi, then halfway around is 1 pi. So this is pi. Okay, so then furthermore, if halfway around is 0 to pi, then what's half of the half? Well, half of pi is pi over 2. Half of a pi. And then conversely, now I kind of think about it in terms of decimals now, like, okay, I'm at 0, 1/2, 1, 1.5. So this is going to be the 3 pi over 2 spot. This is where I'm going to run out of room down here, so I'm sorry about that. So 3 pi over 2 is the very bottom, and then back to 2 pi. So you can kind of count it. You can go, okay, half, whole, 1.5, 2. So have them evenly distributed through the 4 spots. Okay, cool. Well, from here, let's go ahead and build the 45s. They're just halves again, half of halves. So 0 to pi over 2, halfway between that, because 45 is halfway between 0 and 90, so what's halfway in terms of radians? Well, what is a half divided by 2? So if I take a half, if I take a half, a little bit of room here, 1/2 divided by 2, okay, that's 1/4. So this is going to be pi over 4 here. And now this is where it's cool, where you can actually just kind of count it all the way out. So you can go, okay, 0, 1/4, 2/4, because 2/4 is 1/2 simplified, 3/4, 3 pi over 4 is here, 4/4 is pi, 5/4, we're just counting the 45-degree cuts. 5/4, 6/4 is 3 pi over 2, 7 pi over 4 is right here, okay, 7 pi over 4. And then the next piece is 8 pi over 4, and 8 pi over 4 is 2. So you can see that all the 45s are just going by a quarter every time. And 45 is divisible to 45, 90, 135, 180, 225, 270, 315, and 360. So the 45s are all consistent as well. Okay, so that's the 45s and the endpoints. Now the 3060s are, I wouldn't say they're tricky. They actually do count the same, but they simplify there's an extra level of simplify. And I'll show you what I mean here. So let's switch, let's go to, I'm going to go to red for the 3060s. Actually, let's just stay blue. Let's go all radians here. Okay, so 30, okay, if we think about it here, 30 is 1/3 of the way from pi over 2. So what if I did pi over 2 divided by 3? Pi over 2 divided by 3, if I do that little work down here, that's going to be pi over 6. So this is pi over 6 right here. So I'll write it right here. Okay? Well, pi over 6, if I went 30 to 60, that's just double, right? 30 to 60, I doubled it there. What's pi over 6 times 2? That's 2 pi over 6. But 2 pi over 6 reduces to pi over 3. So it's just a lot of fraction simplifying with these. They're really not too bad once you get the pattern down. And so now watch this. I'm going to count the first section for you. 1 pi over 6, 2 pi over 6, 3 pi over 6, the 90. Count by 30s, right? 30, 60, 90. 1 pi over 6, 2 pi over 6, 3 pi over 6. 3 pi over 6 is 1/2. So then the 120 is going to be 4 pi over 6. But what does 4 pi over 6 simplify to? 2 pi over 3. And then I have 5 pi over 6. That doesn't simplify, so we leave it like that. 6 pi over 6, which is 1 pi, 6 over 6. 7 pi over 6, that doesn't simplify, it stays that way. 8 pi over 6, which simplifies to 4 pi over 3. 9 pi over 6, which is 3 over 2. 10 pi over 6, which is 5 pi over 3. We've done that one a couple times in our notes. And then we have 11 pi over 6, which doesn't simplify here. And then 12 pi over 6, which is 2 pi. Okay, I'm going to erase this guy out of the way so we can see all the radians there. So there's all your radian cuts. Let me go through it one more time. Okay, so when we're going through the pi over 6, the 30/60 cuts, they work together. 30/60, we got 1 pi over 6, 2 pi over 6 or pi over 3, 3 pi over 6 or pi over 2, 4 pi over 6 or 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6 or 4 pi over 3, 9 pi over 6 or 3 pi over 2, 10 pi over 6 or 5 pi over 3, 11 pi over 6, and 12 pi over 6 is 2 pi. Okay, so there's your breakdown of your radians and your degrees. Okay, so the next piece I'm going to talk about how the coordinates are created. So it's important to know, and I'll go ahead and just draw one on this sheet before I change pages here, but it's built through triangles, and these are how the triangles are made, because we know we're on an xy coordinate, right? So when I put a point here, to figure out what that point is, well, that point is an x value. Okay, let's change off of this. This is an x value and a y value. That gets you that location. Well, this value for all of these is 1, because that's the radius. That doesn't change. What changes a little bit is the x and y value. We're going to talk about that next. So it is built through triangles is the point. Okay, so let's talk about that next. So what leads us to what gives us the coordinates? How do you know the coordinates? I'm just going to go do the spoiler alert. I'm going to tell you the coordinates we expect. 0, 1/2, root 2 over 2, root 3 over 2, and 1. Okay, so the n2, those aren't on the part of the triangles because those are actually just direct points from the straight out, straight up, straight left, and straight back. All of these can be plus or minus, so just keep that in mind for the unit circle depending on what quadrant you're in. But here's the deal. Now these triangles aren't to scale. I just made them quick on here. They're just right triangles. I just added to the slide here just so that we can, whoops, I don't want to make that smaller. I want to move. Okay, there we go. Just want to move it a little bit. Okay, so we're just going to call this one my 45. Okay, so we're going to say this is 90, this is 45, this is 45. And then we're going to call this one our 3060. And again, I know they're not to scale. Don't concentrate on that. Just concentrate on the idea. Okay. Now, with a 45, 45, we know those triangles are isosceles, so we know these sides are the same. Okay? Now, by knowing that, we can figure out, so we know right there, this right here is the radius for our unit circle. So that's the radius for our unit circle. We can solve for these two missing sides here, which in this case, it's going to be x and y for us, but we're going to treat them both as x because we're just solving for the value right now. But here we go. What we're going to do is we're just going to go x squared plus x squared equals 1 squared. Okay, x squared plus x squared is 2x squared equals 1. Divide the 2. Okay, so then we get x squared equals 1/2. Square root, square root. That gives me x equals 1 over root 2. We rationalize. And you see one of the coordinates that I just showed you at the top, root 2 over 2. So when you have a 45-degree triangle and a hypotenuse of 1, the side lengths of your triangle are root 2 over 2. So that's why with the 45 cuts, they're exactly the same coordinate. The x and y are the same, root 2 over 2, root 2 over 2. The only thing that changes is the positive, negative, depending on what quadrant you're in. So there's the work in how we get the 45s. Okay, so let's go ahead and I'm going to erase this now, so if you need that, you can pause the video. Okay, now let's talk about the 3060. So the 3060 is a little bit more unique in the sense it's not, they work together in the sense that it's going to be, we got our 30 and our 60. We know the hypotenuse is 1. And so the pattern with these is a little bit different because, try to figure out the way we can solve for the pattern for you here. Let's see. So let's just get to the chase here. The special triangles for 45, let me back up a sec. We aren't right to solving. I didn't tell you the pattern, but it's okay. You knew that 45s are the same. 45s have the pattern, they're x, x, x root 2 for a special triangle. We essentially we knew the hypotenuse, so we solved for x. Okay. Well, this one we know the hypotenuse, but the pattern, though, for a 3060 is interesting. It's actually the hypotenuse is double the small side, the 30 side. So 1x double 2x for the hypotenuse. And the 60 side is unique. It's x root 3 is the pattern. So we know what the hypotenuse is. So the hypotenuse, 2x, equals 1. So then what does x equal? Well, x equals 1/2. So 1/2 is this piece. Okay, just kind of solve for x in terms of the pattern for special triangles within the unit circles. Because remember, the hypotenuse is the radius, right? So we know that right now, our unit circle that we're dealing with has a 1 here and a 1/2 down there on the 30 side. Well, that was one of the values I had up there, right? 1/2. And so where's the root 3 over 2 come from? Well, see how it's x times root 3? Well, we know what x is. X is 1/2. So it's 1/2 times root 3, which is root 3 over 2. So root 3 over 2 is the bigger side. It's the bigger side because it comes from the 60. So then when you're coming over here, what you have to realize, and we're going to do this on the next circle here in a second, is that you want to look at lengths. So if I asked you, like right now, if we just looked at, let's take the yellow here, let's look at the 30 real quick. See this triangle? What's bigger, the x value or the y value? Just in terms of length. Well, the x clearly is. That's the root 3 over 2 side. This is the 1/2 now. And so that's how you can kind of make the comparison to make your points and coordinates accurate when you're doing your unit circle where you're trying to figure out, hey, what is 135 again, or what is 120? Okay, thinking about lengths. Okay, so anyways, the point is we just derived all the values to the unit circle. So in recap, our values are, we have 0 and 1, which is just your endpoints, so those aren't really the ones we had to solve for at all. But then we have the 1/2 from the 3060, the root 2 over 2 for the 45, and the root 3 over 2 for the bigger part of the 3060. Okay? So what we're going to do now is, in the last slide here, we're just going to go through and we're going to put all the coordinates. Okay? All right, and then I'll just show you the final one from the book here. All right, so let's just do this real quick. So we got, remember I'm human here, so these won't be perfectly straight lines. We'll do the best we can. So we got our 30. Let's do our 30/60s first. We'll do 45 last, which is kind of the easiest one anyways. So 30/60, 60 away, 30, 30, 60, 30, 60. All right, so I'll just label them for degrees for being simple. We already did the radian part, so here's the 30. So the 30-degree cut, what is that value? So again, we know that our values we're using are, one more time, 0, 1/2, root 2 over 2, root 3 over 2, and 1. And we know right now, as I told you, we're doing 30/60s. We're doing all the 1/2 root 3 over 2 spots. So this 30 cut, we just talked about in the previous slide with the yellow there, clearly the x is bigger. So x is my root 3 over 2. Now, how this works is that unit circles are essentially, they're symmetric. So this value here is the same as this value here. It's going to be the same point. The only thing that's going to change is the sign. So this right here is still root 3 over 2 for x, 1/2 for y, but I'm in the second quadrant, so I know my x is negative. And then conversely, see this right here? That's going to be the same, because this is also the same cut. So let me outline this for you. So this line and this line, all those yellow endpoints are going to be root 3 over 2, 1/2. The thing that's going to change is the sign. And it makes sense because all these lines here, look at them. The y value is the small piece. And so they're the 1/2 every time. Okay? So let's go label these then. We're done with those. Those are the 30-degree reference angle cuts. So we have root 3 over 2, negative 1/2 here. This is the, I didn't label the degrees here. So this one's the 150. This is the 210. Okay, and then over here I'm at 330. And that point is root 3 over 2 positive, because x is positive here, negative 1/2. Okay, now let's do the 60 cuts. So 60 cuts, they're just the same exact point, but flipped, because now, let's do these ones in blue here. Keep going the color coordinated. Hopefully it's helping, not making it worse. Okay, we can see clearly the x is the smaller piece now. So since the x is a smaller piece, that's going to be 1/2 for my x. And this point right here is going to be the 60 cut. So it's going to be 1/2 root 3 over 2. Okay, this one's also the same right here. So this is going to be negative 1/2 root 3 over 2. Oh, that's bad. Let's reset. Try to make that bigger. Okay, so negative 1/2 root 3 over 2. And this is 120. Okay. And then, just so you know where I'm going here, just now look similarly, this line and this line are going to have the same exact coordinates, just the sign changes. Those are all the 60 cuts for reference angles. Okay, 60 cuts. Again, you can kind of see because all those spots, the y's are bigger. All right, so then down here, we have negative, negative, so negative 1/2, negative root 3 over 2. This point, that angle measure is 240, and then 300 is right here, and this one is 1/2 negative root 3 over 2. Okay. All right, so that's all the 30/60s. That one's kind of the hard one. The 45s are the super easy ones. Okay, so let's draw all those spots, and we'll be done. 45, 45, 45, and 45-ish. Okay, so here's my 45. In the positive, it's root 2 over 2, root 2 over 2. Okay, over here, my 45, this is 135. This is root 2 over 2 negative and root 2 over 2. Okay, here's my 45 in the third quadrant. So that's going to be 225 root 2 over 2 and root 2 over 2. Man, run out of room here. Let's erase that again. It's not good. Okay, it's both are negative. Okay, sorry, it's hard to see. Root 2 over 2. And the last one over here is the 315, and that is a positive root 2 for x, negative root 2 for y. So again, there's your unit circle, all in a nutshell. I didn't put the 0, 1s and the pi's over 2s and all that stuff, but you had that from the first slide. But that's how it's built. That's where it comes from. So when I say it's a pattern in the sense you can also see one thing to kind of pay attention to, and the last thing that I'll say before I show you the last slide here. Notice the x values, as you're going to the left, are getting smaller. Root 3 over 2, root 2 over 2, 1/2, 0, negative 1/2, negative root 2 over 2, negative root 3 over 2. So see the x's are slowly getting smaller to the left, and the y's are getting bigger until it hits their peak here, 1/2, root 2 over 2, root 3 over 2, 1, and then it starts coming back down for the y's. See that? And so you kind of see the growth of the x and the y and their interchange of their pattern in terms of lengths. Okay, so it's kind of neat. Okay, so I hope that helps. Here is the unit circle, just filled out, definitely cleaner than how I was writing it. So if you're trying to scribble it down on the previous slide there, here's what you really wanted to see. But hey, if you need any help, feel free to email me. Just even if you're not from school, tbanker at edgeschool.com if you have any additional questions. Okay, unit circle crash course for you. Thanks.